Welcome to the Explainer. So today we are going to break down one of the most complex, most incredible machines ever built. And we're going to do it by following a single, absolutely daring mission from the fiery launch all the way to its nail-biting landing.
So let's just dive right into the heart of the action. It's a spring evening in 1992, and we're on board the Space Shuttle Endeavour for its very first flight. The mission? Something totally audacious, a satellite rescue. And as you can see from that quote, this was no ordinary satellite. Okay, so here's the deal with this daring rescue mission, the stakes for STS-49. You've got this multi-million-dollar satellite, right? And it's just stranded. It's stuck in a completely useless orbit because its own rocket failed. So the crew of STS-49, they were given a job that, get this, had never been done before. They had to go up there, grab it by hand, and bolt on a brand new engine. But, before they could even think about any kind of rescue, they first had to survive the launch. And calling it a launch feels tame. It's more like a controlled cataclysm, an incredibly violent but also precisely engineered event that all starts with this mind-bending final countdown. All right, these final seconds are just wild. It's this rapid-fire sequence of events. So when the three main engines ignite, they're not perfectly centered. This actually causes the entire 2,000-ton structure to bend forward. I mean, can you imagine? The whole thing tilts over before it's even left the ground. NASA actually called this the twang, and it literally has to rock back to vertical before it's cleared for liftoff. It's insane. And then T0. This is when the real show begins. The two largest solid rockets ever flown just ignite. We're talking about each one generating over 13,000 kilonewtons of just unimaginable force. And the only thing holding this entire beast to the launch pad? Just 8 explosive bolts. 8. So this brings up a really important point. The difference in control here. You see, the shuttle's main engines are these sophisticated, precise instruments. You can throttle them, you can even shut them down. But for those first 2 crucial minutes, most of the power comes from the solid rocket boosters. And those, they are just pure, unstoppable force. Once you light that fuse, well, there's no turning back. You are going for a ride. So that begs the question, right? How in the world do you control the uncontrollable? Well, the engineering here is just brilliant. They designed the fuel itself to throttle back automatically. It was cast in this amazing 11-point star shape. Now, that shape gives you a huge surface area at first, which means massive thrust right at liftoff. But as it burns, the points of the star burn away, the shape becomes more circular, the surface area gets smaller, and that throttles the engine down. It's a self-regulating rocket, all to keep the shuttle from being ripped to shreds by atmospheric pressure. Okay, so after 2 minutes of riding that raw power, the boosters are spent, and they separate. But this isn't some gentle uncoupling. No way. It is a shockingly explosive moment. Just listen to how astronaut Bruce Melnick describes it. A massive bang, and then suddenly the whole cockpit is engulfed in a fireball from the separation motors. For a second, you'd think the whole thing just blew up. All right, they made it. They're safely in orbit. And now, the whole mission shifts. It goes from all that brute force to delicate precision. But that transition from the violence of the launch to the absolute quiet of space, it brought a pretty profound surprise for the crew. And here's what happened. The moment they hit the quiet of space, what they call main engine cutoff, the view of Earth was just so breathtakingly beautiful that, well, Melnick completely forgot his first job. He was supposed to be photographing the external fuel tank as it fell away, for analysis, but he just choked. It's such a wonderfully human moment, right? In the middle of all this high-stakes life-or-death engineering, he was just a guy, blown away by the view. So back to the mission. After 2 full, frustrating days, the main objective was failing. The special capture bar they'd built just wasn't working. Ground control was ready to call it a day, but the crew, they came up with a new plan. A plan so audacious it had never even been simulated. They said, what if we send 3 of us out there? This led to the first and only 3-person spacewalk in history. This was completely off script. They had to solve this crazy life-or-death puzzle on the fly. How do you cram 3 people into an airlock built for 2? The solution was to have one astronaut floating upside down, running only on his suit's limited internal power. Just an incredible, incredible act of human ingenuity.
They did it! The satellite was repaired and deployed. But now the crew faced their next great challenge: getting home. And that meant surviving a literal trial by fire. Okay, let's talk about re-entry. It starts at, are you ready for this? Nearly 30 times the speed of sound. The friction with the atmosphere is so intense that it literally turns the air around the shuttle into a glowing plasma. We're talking temperatures hotter than lava, around 1650 degrees Celsius. And for 12 long minutes, that plasma cuts off all communication with Earth, total radio silence. So yeah, the big question is, how do you possibly survive that? Well, the answer is something called the thermal protection system, and it is an absolute marvel of material science. You have to remember, the shuttle's skin is just lightweight aluminum. That stuff would melt at only 177 degrees Celsius. So to protect it, engineers came up with a two-part solution: super resilient carbon-carbon panels for the absolute hottest spots, like the nose and wing edges, and then a blanket of thousands of special silica tiles covering pretty much everything else. And when I say thousands of tiles, the sheer scale of this is just staggering. Look at that number. The belly of the shuttle was covered in over 32,000 of these things. And here's the kicker: they weren't all the same. Each and every one was a unique, individually shaped and serialized piece of a giant, heat-resistant puzzle. What a nightmare for the technicians. So what was the secret sauce? The real magic of these tiles was what they were made of. They were basically solid smoke. I'm not kidding. They were made of silica fibers so fine that 90% of the tile's volume was just empty space, just air. This made them incredibly lightweight, but also fantastic insulators. So effective, in fact, that there are famous videos of someone pulling a tile glowing red hot from a 1200-degree furnace and then holding it in their bare hands just moments later. Unbelievable. Okay, so they've survived the inferno of re-entry, but the mission isn't over. The final, and you could argue the most nerve-wracking challenge still remained. They had to land a 100-ton aircraft with no engine power. Think about that. It was basically a glider, a very, very heavy glider. Some called it a controlled crash, and they had exactly one shot to get it right. No go-arounds. So how do you land a brick? The shuttle couldn't just point its nose at the runway and glide in. No, it had way too much speed. So it had to perform a series of massive high G S-turns, banking it up to 70 degrees, basically scrubbing off speed in the air. Then it would enter this incredibly steep glide slope. We're talking 20 degrees, way steeper than a commercial airliner. It was essentially diving at the runway before the commander would pull the nose up in this dramatic flare maneuver at the very last second for touchdown. Yeah, there's a very good reason pilots gave the shuttle the nickname the Flying Brick. When you compare it to a normal glider, which kind of soars gently and elegantly, the shuttle was this unwieldy beast. It didn't soar, it fell. It basically fell out of the sky with style, hitting the runway at a blistering 360 kilometers per hour. A typical glider lands at maybe 80, just a whole different ballgame. So when you look at the whole picture, from that unbelievably violent launch and the on-the-fly rescue mission to the fiery descent and that pinpoint landing, you realize the shuttle program was just constantly pushing the boundaries of what we thought was possible. It was an incredible machine. Flawed, for sure, but also beautiful and ambitious. And it really does leave you wondering, what's the next great engineering leap we should take on? What's worth the risk?